Welcome to the joy of coding.
Hello, and welcome to episode 89 of The Joy of Coding. I'm pretty sure it's episode 89. Someone's just asking when the live stream is going to start. Right now. It's starting right now. Fisher in the live hacking chat room wanted to know when it's starting. Well, we're starting right now, and I'm pretty sure today is episode 89. Let me just double check. Is it 89? It is. Hi, I'm Mike Conley. I hope you're excited to be here. I sure am. Today we're going to be hacking on some Firefox Mozilla stuff. I'm going to be probably writing more Rust today, or maybe not. It depends. I might be doing some C++ today, or not. It depends. I'm probably just going to flip a coin in my head. I'll explain in just a second. So here's my screen, and here's the agenda. So the agenda is how I kind of lay things out for the episode. If you're new, you might not know that. So this agenda is, even though it's kind of a plan, I want to remind you that no plan survives breakfast. And for the people who are watching, on Twitch, I should give you this link too. So I'm going to drop this link into the chat on Twitch. Bam! There you go. No plan survives breakfast. So even though I kind of have a sense of where I want things to go with the stream, it may or may not happen. I might change things on the fly. I might get distracted with something. Who knows? But this is just a general outline. So first of all, is everything working? I want to make sure that you can hear me. Yes, I'm audible. Do the sounds work? They seem to. I am recording. Excellent. So there are a couple of things I want to lay out. First of all, you may or may not use Facebook, but if you do, and if you'd rather watch this video on Facebook, or you know people who'd want to watch this video on Facebook, I now have a Facebook page, and if everything's going okay, and it appears to be, I'm just checking all these different sources, everything seems to be working, then I am currently streaming to Facebook as well as Twitch and Air Mozilla and YouTube. So if that's where you want to watch this video, you can now. There's a link in the agenda, and if you need to get access to the agenda, which I imagine some of you might, if you look in the video description on YouTube, there's a link there. And if you're on Air Mozilla, just scroll down to the additional links section. There should be a link to the agenda there. And if you're on Facebook, shoot, I don't know what I'm going to do because I wasn't able to insert any kind of like description of the video. I couldn't put a link in. I better figure out how to do that. So next time you'll get a link, hopefully. I think I said that last week too, and I think I didn't do it. So hopefully next week. Fingers crossed. But now I have a Facebook page. Hooray! So what are we working on today? Today I am going to do one of two things. I'm either going to work on this bug that I've kind of had on my backlog for a while, and I've poked at it, and I don't fully understand it, and it's kind of frustrating. And another bug where I might work on some Rust stuff. We did it a couple weeks ago. And I've made some progress on it. I wrote some patches for it, and we'll try and progress on that. So it's one of these two things. I think I'm going to do this first one, the C++ one. It was above in the list. I'm just going to do that. I put it off for too long, and I've been trying to work on it, but I don't fully understand it. And I will explain it to you, and hopefully, whenever I explain it to you, I will start to understand it as well. So what are we talking about? Yeah, this is the bug. Bug 1312883. So BHR should collect native stacks instead of pseudo stacks on builds with frame pointers. Okay, so where to begin? BHR is a thing that we have built into Firefox called it's an acronym for Background Hang Reporter. So we have all these different threads in the browser. I mean, there's the main thread, which does a lot of the like painting of the user interface, and it accepts user events and stuff. But we also have a bunch of different threads, and whenever those threads get bogged down by something, the background hang reporter notices. It'll notice that the thread is slow, and then it will do what's called collecting a stack, collecting a hang stack. And up until now, or even right now, what it's doing is it's collecting what's called a pseudo stack. You can actually view these pseudo stacks. If you have telemetry enabled and you go to about:telemetry, that's what I did up here, If you have telemetry enabled under thread hangs is where the data is going. And so what we have here is a histogram showing approximately the length of the hang that occurred with this particular stack. And if you have multiple hangs with that same stack, you'll get something like this where you have two entries. So you'll eventually, over time, if a hang keeps occurring in the same place, you'll get a sort of a histogram of how slow it is and how long the hang lasts, etc. But these stacks are very useful, or they can be useful in determining where we need to speed something up, because it means that we're slowing down. These are all on the main thread, for example. These hangs are all on the main thread, and that means that we're blocking the user interface from responding. So what do we have in here? I must have opened up the add-on manager at some point, and I had a hang of somewhere in the neighborhood of half a second. That's not good. What else? Anything else of interest in here? PDF.js was doing the thing, and it took a while, and that's half a second. And over here, I was running a garbage collection. GC runtime collect ran. That's the garbage collector, and that ran for 120 milliseconds. That hung the main thread for a little bit. So these are kind of useful. Here's another one. For 256 milliseconds or so, it looks like we were getting the user's cookies so that we could probably persist them to disk, and that took a little bit. And that took a little while. And we have these other threads as well, like the compositor thread and the vsync thread and the image bridge child and the process hang monitor thread. None of these threads appear to be hanging. This first one is called this dash activity. Um, it it's sort of like a count of how often actually, I don't exactly know what the dash activity histogram means, but it doesn't mean hang. I know that much. All the other ones mean hangs. And so we've got a bunch of main thread hangs here, and that's not good. So why is that interesting? Well, we not only collect hangs on the main process, but also in any content processes. So here's the child process. We've got main thread hangs here. We also have what's called the gecko child force paint hang thread list here. So what is that? That's a thing I added. That is a special background hang monitor thread that listens to the main thread. So we have two things listening to the main thread in the content process, but this one's special because it only records if we're in the process of doing a tab switch. Okay, so this is a thing I've been dealing with for a number of months now. You might be familiar with it, is trying to improve the performance of switching tabs. And so if I can detect hangs that occur during a tab switch, that's good. I could collect that data, and then we could see where we're being slow, and we could try and optimize. But there's a problem, and the problem is that a lot of the data I get for these hangs is pretty useless. Like, let me show you. I have a publicly listed set of hang on, I have to log in. 1 second. I think this should work. If I just log in like that. Okay, so I have these telemetry tools that are doing the work of producing results, these stack results. So this is the one from yesterday. And this is just a JSON, assorted JSON list of thread hang signatures. And it's pretty big. It's a pretty big list. But we can take a look at the raw data and try and figure out what we're seeing. I'm going to pretty print it. And unfortunately, one of the things we see at the very top is this really useless stack. It just means startup : XRE init child process. And what that means is the content process is running. So we're hanging most of the time, like more than double the amount of time in double the number of hang hits than we get in the second one. In the first one, like the number one hang is just we're running the content process. And that's useless because I don't know where in the content process we are. This is what we call a pseudo stack entry. So the pseudo stack is not a native stack. If you've ever used a debugger or something where you can get the stack, the call stack, that's useful. A pseudo stack is like we've annotated certain functions so that we can kind of collect a stack if you're in those functions. And all we get are the entries of the functions that you have passed into to reach the line of code that you're at. So it's like a kind of made up stack. We're able to get that and JavaScript, and we sew those together, and that's what we get. So we have some pseudo stack entries here, so we know that we have like we've started the child process, we're in a mouse event thing, we're dispatching an event, and then some website JavaScript runs, and we must have hung. But that's not super useful. It would be great if we could get what's called a native stack. A native stack is what I described before, is like what you would get if you attached a debugger and hit BT to get a backtrace, like an actual native stack. And we're able to get a native stack using some of the like other tools are able to get a native stack. Most notably is probably the Gecko profiler, which if you capture a profile, if you're familiar with the Gecko profiler, it will this is a native stack that we're looking at here. You can tell it's a native stack because oh, it starts unsymbolicated. So it's just memory addresses of where the functions are. And then there's this little notification up here saying that it's getting the symbol table libraries, symbol tables for the library. And so that's going to take a while to download. But once it does, it will resolve these memory addresses to actual function names. And that's useful because then I know where exactly in the program we were. So that's what we want. I want BHR. So that's what the bug's about. BHR should collect native stacks instead of pseudo stacks. And maybe it should always collect native stacks, or maybe not. Maybe it should, because collecting pseudo stacks is really, really cheap. Collecting native stacks is expensive. And I'm wondering if maybe we should only collect native stacks in like particularly bad hangs. So look, this profile just symbolicated, and we can see where I am. Like those memory addresses resolved these functions, so that's good. So that's what we want to be able to do, is collect native stacks instead of pseudo stacks. But I think we only want to do that in particular types of hangs, particularly bad hangs. So Background Hang Reporter, or BHR, was actually designed with this in mind. There was, let me see, I've got my notes here. I've got notes for this bug. You should follow along if you've got the agenda in front of you. There is a file called threadstackhelper.cpp, and there is a get native stack. So thread stack helper and get native stack. Get native stack is a method that BHR can call to get a native stack. Great, except that it doesn't actually do anything. Right now, it's actually just getting the pseudo stack and not doing anything with it. We're not getting the native stack. We're not combining the two, because that's a step. You have to combine the two stacks. It's just getting the pseudo stack. And that's not enough. So we have to do the actual work. Like it looks, there's a to-do here to walk the saved stack frames, and it used to work actually. So there used to be code in here that did the native stack gathering, but it did it in a kind of a funky way using some of the old crash reporter infrastructure to get stacks. And now that we have the profiler built into Firefox and Gecko, we can use that backend instead, and that should be, in theory, a lot easier. So that's what we're doing. That's the plan, and this has been very intimidating. This is a very intimidating bug. I'm intimidated by this bug, and what I like to do when I'm intimidated by a bug is try and split it into smaller bugs that don't intimidate me as much. So let me pump up the font here, and then maybe we can break this down into some smaller chunks. So what I did most of all was, like, I was doing some exploration of what this already does, and I also started to look at what we used to do when we were using the old crash reporter infrastructure that was ripped out in Firefox 43. So that was using the breakpad infrastructure. This was the review request that got rid of all of that stuff, and so we can maybe look at that as an inspiration for what needs to happen whenever we finally get down to it. So for example, you can see that we're getting the pseudo stack, and then what it does is it calls into Google Breakpad. Breakpad is the crash reporting library that both Firefox and Google Chrome use. I think Google Chrome still uses it. And it's called Breakpad. And then we build like a stack walker thing maybe, and then we must do something. Like we gathered a stack before, and we'd gotten some kind of context, and then all this stuff happens, and then we appended to the stack. We just did like append via buffer at the end, and I'm not sure if that's all that needs to be done, and like you don't actually have to walk or like I don't know if there's any kind of like sewing together pre-processing that occurs. I have a feeling it's just going to append it to the buffer, and then maybe whenever we end up processing the telemetry, we'll do the work of actually like combining the two stacks and uh, symbolicating them as well, because you don't want the browser to do that, because the browser's already in the middle of doing something busy. I mean, when we do this, the browser is hanging, like a thread is hanging, so we don't want to give it a bunch of extra work. We want to make it do the minimum amount of work possible, so to collect the data, and then we'll do the work in post-processing after the fact when we've got like a big cluster of machines and run some Python to do that. So maybe that's all we need to do is just like append the stack, and then we'll do all the post processing. So maybe this is not as bad as I thought it was. Now that I think about it, because I just kind of thought of that idea of doing it with post processing. And let's see, how is it gonna do it? It ends up creating like just a string that goes through each of the frames, and then it appends it to the stack that was created back here. So there is an append via buffer method. So let's take a look at that. And what does it do? Append via buffer. What does it do? I think this is the one, right? Like that's the one that we're talking about, right? Thread stack helper. Oh, there's also infallible append via buffer. Maybe we want that one. Infallible append via buffer. Can append without reallocating. Include null terminator in length count. And then we just append a bunch of stuff. So I guess this one's fallible. This one is infallible. This one cannot fail. This one might fail, because we might not be able to reserve the amount of memory. Oh, wait, and this one's called via append via buffer. So this will return null pointer in the event that things have gone wrong. And if things go right, then we'll return the memory address of the buffer that I guess we created. Interesting. Posture entry. Puts that on the stack. Buffer end. Buffer end. So we get a pointer. We return a pointer to the end of our buffer. So I see. We return a pointer to the point where we had started the insertion, which assumedly overwrites the previous null pointer. Okay. Because, yeah, we include null terminator in length count. Right. Gotcha. Okay. So maybe it's as simple as just gathering the stack. The reason I say that is because now that I think about it, I seem to recall there being like some old Python that I'd seen on like GitHub, I think. GitHub Vladin. There was a fellow who worked for Mozilla who had written some Python that sounds like it might have done the post processing. I want to see if that's what actually happened. Mozilla telemetry. Mozilla telemetry. There's a repository for Mozilla stuff for telemetry. I'm trying to find out where it is. Telemetry dashboard. Maybe that's it. Yeah, I think this might be it. Or no, you know what? It wasn't this. It's something else. There's a fellow, Jay Chen. Jay Chen? GitHub, Jay Chen. Jim Chen. That's not quite who I'm talking about. The reason I want to just make sure I understand how this all works. And I remember Um, I gotta find his GitHub account. I gotta find Jim Shen's, because Jim Shen was the guy who actually did the removal before, and he was the one who like fully understands BHR. He's still around. He's still involved with Mozilla, but he's doing other stuff now. Jim Chen, Darkons is his IRC nick sometimes. And here we go. Hang telemetry tools. He does a map reduce on BHR. Map ping. Map ping does, like, is there anything up here about native stack? If native stack, neither has native stack, one has a native stack. Merge native stack info. So he does do the merge in post-processing. Ah. Okay. Okay, so we're actually in good shape here. We just need the native stack. We don't need to do all the sewing together. That relieves me quite a bit, because I think we can do that. We might even be able to do that this episode. So try to use Moz stack walk like Gecko sampler to collect the native stack as a string and then append it to the a stack variable. That's what we're going to do. And I think that might, oh, whoops, I didn't want to do that. I wanted to make that look like code. So I do that with, what do I do that with? For Dana? No. Monospace. That's what I generally do that with. Monospace isn't even listed here. Ah, forget it. Okay, so let's do that. So where are we going to do that? So first of all, let me make sure that I've got a proper build. What have I got on the tip of the tree, the tip of the tree? Oh, and that, yeah, I might want to work on that too. If we get blocked on this, I'm going to have to work on this bug. Whoopsie daisy. Because it got backed out last night, and I need to get it landed. So I'm going to put that in the agenda. Now that I've updated Central, I'm going to put that second actually. Notes. The notes. Link up the notes to it. Copy public link. So I'm just hooking up what might be the next thing if I get blocked on what we're about to do, or if I get it done a lot really quickly, which fingers crossed is what happens. So I've updated my source tree. Sorry, you probably can't see that. I've updated my source tree to central. Now I'm going to build. And while we're waiting to build, let's see if we can figure out where we're going to be doing our work. I'm going to close a bunch of the stuff that I don't need anymore. Don't need that. Don't need that. Don't need any of these. So we're bare slate, clean slate. What are we working in? Well, we're going to work in the part where we were originally getting, I had written it down here in my notes. The thread stack helper, this entry point right here. Get native stack. So that's where we're going to be. This is in the file threadstackhelper.cpp. Let's do that. Threadstackhelper.cpp, and then there's a function here called getNativeStack. We're going to look at that. And so Gecko profile, we're now going to look at how the Gecko profiler does it. Gecko sampler, I think is what it's called. No? Moz stack walk under profiler. Here we go. Oh, and then there's also frame pointer stack walk. When x64 doesn't support disabling frame pointers emission, so we need to fall back to using stack walk 64, which is slower. And Moz stack walk. Which one is preferred? There's Native backtrace. Stack walk callback. Start with the current function. We use 0 as the frame number. Huh. And we have this native stack struct thing. Get the number of max frames, and then we walk the stack. What does it mean to walk the stack? So stack walk callback. Oh, this is just. Oh, I understand. This just adds. So I have a feeling this is the structure that we're gonna hold the stack in. We call stack walk callback with 0 at our self. I would imagine that that's because we're going to start with the current function. And then we do this subtraction here, native stack size, count. Where is it getting those from? I have better look at and see what the definition of native stack is. Struct native stack, PC array, SP array, size, and count. And then it calls stack walk callback. Stack walk callback, what is stack walk callback? We'll get the native stack, and then it's going to just, pass in some void star things, and then increase the count, I think. Yep. So that's not a big deal. And then, so we look at the sample program counter. SP is probably program counter. I don't know what SP is. It's unfortunate. These are really terrible variable names, PC and SP. I don't know what that means. Then we do a subtraction from size to count. And then we get the samples thread profile, get stack top is stack end. And we do what's called frame pointer stack walk. Frame pointer stack walk, what is that? And we only do frame pointer stack walk if we're on OS X or we're on Windows, on 32-bit Windows. I see. What's frame pointer stack walk? I see. Moz glue stack walk. Interesting. Interestingly, Moz stack walk calls frame pointer stack walk. And how does Moz stack walk work? Are there multiple? Oh, there are multiple implementations depending on probably your, yeah, depending on your platform configuration. Multiple implementations. If defined XPWin, OS X, or Linux, then this is frame pointer stack walk. I see. It'd be great if there was like documentation here. APIs for getting a stack trace of the C or C++ stack on the current thread. So the callback from us. Oh, luckily there is some nice documentation here. So a Moz stack. a Moz walk stack callback. It's the callback for Moz stack walk. Moz stack walk. May skip some stack frames due to compile optimization or code generation. So it looks like you can pass in whatever structure you want to Moz stack walk, and Moz walk stack callback will get it as the closure, and then with the information that you get, yeah, the best approximation possible of what the stack pointer will be returning to when the execution returns to executing that at APC. If no approximation can be made, it will be null pointer. The program counter value. Okay. And then the frame number. Okay. So it calls frame pointer stack walk immediately if we're on OS X or on 32-bit Windows, because 64-bit doesn't support disabling frame pointers emission. So we need to fall back to using stack walk 64, which is slower. Stack walk 64, where's that used? In stack walk 64. 32-bit frame unwinding. Debug routines are not thread safe, so grab the lock. And this is inside walk stack main 64. And walk stack main 64 is called in a bunch of different places. Walk stack thread, walk stack main 64. Moz stack walk is what calls it. So maybe we should just trust. Maybe we should just trust. Although I'm getting a little overwhelmed here. Getting a little overwhelmed. Let's just try this part. Let's avoid this complication. Let's pretend that, well, actually, come to think of it, because I'm on an OS X machine, maybe let's do this. Let's see if we can call this and do something kind of similar, where we native stack, stack cast, native stack. We'll construct a thing. We can construct it however we want. And what did the old thing used to do? Like whenever we removed it, what were we? We constructed a string for each frame. We just did like the raw instruction, and then we did like base address and instruction. And this structure, this frame, what is a frame? It's a stack frame, Google Breakpad stack frame. And is there any kind of structure that we can use that is reusable inside stack walk? Let's look at stackwalk.h. Is there a reusable structure that we could use in here? Here's a struct, Moz code address details. Not really. Not really. So I think we have to invent our own like structure. And then I guess we can, because there's no, we can kind of invent our own post-processing step. So like what we did before was we just put in the instruction minus the base address, so the actual like memory address, the module name, and then the memory address. So let's see if we can just get the memory addresses. Let's do that much. I'm gonna write some code that calls, let's see, gecko profiler sampler. I'm gonna write some code that just does the walking of the stack. Um, here with this. We're going to do this stuff. And I'm going to pass it a structure, and that structure is just going to, like, I guess, be a string that takes in the, what do we get? A program counter, stack pointer. That's what those are, right? Program counter value and the stack pointer. Okay. Let's just do that. Where are we in our build here? Still building. Still building. I think I did a pull and a rebase, which is why that's still building. That doesn't mean we can't write some code. Just won't save it. So Mom's thread stack helper native. What do I want to do here? I want to call frame pointer stack walk. Frame pointer stack walk is something we get from stackwalk.h, which I think we import at the top here. We're going to want to do something similar inside here. Yeah. Mozilla stackwalk.h, and then we want to call frame pointer stack walk. Like, this is how it was called in the profiler, and let's see if we can figure out what to do here. So max frames, I'm going to make that be, I'm just going to hard code that to 50 frames. I'm just going to pass in null as the closure. And then what do we want? It wants, what does it want? A thread. The thread for which the stack is to be retrieved. Pass null causes to walk the stack of the current thread. On Windows, this is the thread handle. It is currently not supported on any other platform. So I guess I'll pass in null for now. And then platform data. Platform specific data that can help in walking the stack. Okay, I'm going to pass null there as well. And then stack walk callback, I'm going to define that as, let's see, a static method. Okay. Oh, and there's a context here. Thread context. Instruction contains valid data. Processor context, stack area, start of the stack area, stack size, end of stack area, and then a processor context. Limit copied stack to 4 kilobytes. Max stack frames 32. So maybe this is what we should be passing around actually, thread context. What was this used for before? Or is it already used for something? Thread context. Yeah, we can create this context pointer We don't do anything with it. M context pointer. It's thread context, context pointer. M context to fill, context. Create a thread context, and then we don't do anything with it. Here we can fill the thread context where we need to remove the dependency on breakpad structures. I don't know, do we need this? Oh my goodness, this is pretty complicated. Oh boy. I'm getting overwhelmed. Alright, well, right now I'm not going to pass anything. I'm just going to take this call back, and then I'm just not going to do anything. I'm going to return. And this is a static inside of thread stack helper. My build failed. Why did my build fail? Oh. Unknown. Hang on, I've just been asked to look at something. Let me just take a quick peek at what this is, make sure it's... Okay, I'm adding this to my plate. I've just been asked to work on this. I will now add this to my plate. So maybe we can work on that if we don't run out of time. But I'll work on that in a second. Okay. Okay. Let us... What are we going to do? What are we going to do? We have a build failure. Native stack, unknown type name, native stack, inside thread stack helper in 320. At 320. It's never heard of native stack. What? Where is it seeing this? I think maybe it just built it at a bad time, because I don't see that line in there. Maybe I was halfway through a paste. I had pasted a thing and hadn't removed it. I accidentally hit save, and it tried to build that. So, see if this satisfies it. Quickly gonna check the chat, see if anyone's talking. Hello, Biker1511. Nice to see you in the chat. What else do I... Oh, if you're interested in joining the chat, there are instructions in the agenda on how to do that. There's like a web client that you can use if you don't want to get yourself an IRC client. There should be a link in the agenda if you want to join me under chat. So if you click on the link at the bottom here, let me even just put this in better text. This is a link to a web client that you can use to chat with me from your browser. And then I will link that. So if you click on that, that should take you to a tab that looks like this. Unfortunately, there are a bunch of ads. Some of them can be kind of questionable. Hopefully that's okay. And then it's auto-filled my name as Raisin. That's fine. I'm going to go. I hit go, and then I just wait a second. The UI is not amazing, but I just wait a second. And eventually, I'm in the chat. And at the bottom here, I can like type in some words like hello from Mibit. Mibit is the name of the the IRC client. And I can see that. I can see that over here, and I can respond. Hello, Raisin. That's me talking. I'm M. Conley, pipe live hacking. So if you've been looking for a way to chat, that's how you can do it. Just look at the agenda. There's a link there. Okay. So it looks like this is building properly now. Or some warnings. Hopefully it doesn't take too much longer. I'd like to keep moving. In the meantime, what was I pointed at just now? Someone pointed me at a bug that they said I needed to fix. Let's take a quick peek at it while we're waiting. Crash reason does not appear in mini dumps submitted via the info bar. I think we don't get the crash reason since it's attached via prepare child exception time annotations. What is this? That function writes its annotations into a temp file that I believe doesn't get picked up by the info bar code. When we fix this, we should also make sure that the shmem code is updated as well. Communicate crash metadata through shmem. Is that an abort reason? Okay. Function writes annotations into a temp file. What's the temp file? Just waiting for that build to finish. We can start exploring this a little bit. Crash reporter. Prepare child time annotations. Go to the definition. What is the definition of that? If we're not we assert that we're a child process and then get the temp path. Path separator, build temp path. Generate and append the file name. Open the file, write out any annotations. Memory, global memory status. Reason. Okay. So we write it to the file. And we must close the file, I guess, afterwards. And so how do we know to submit this file? Get the temp path. When was this added? Add support for exception context annotations. Interesting. See how this works. How's this build going? Still going. Build is still going. So how does this patch work? Load the temp directory for sandbox content processes. Defined XPWin or defined OSX. And we've got a sandbox. So for Windows and Linux, we have a sandbox. Or sorry, Windows or OSX, we have a sandbox. Then we get process return, low integrity temp base, dir key. We get special directory, conf process temp base dir key. If on Windows we get win low integrity temp base, otherwise we get as OS temp directory. We create there's some kind of suffix. Then we append here. So we get a file created for us. When do we submit that file, I guess is what I want to know. Modify sandbox initialization code to use directory service to obtain it. To obtain content process temp directory. So what we do is, this is like our sandboxing code. Say the temp environment variable was picked up by the set temp environment variable. Get content process tempter, and then get and clean tempter. Interesting. That happens when we set up the environment. So we clean it up when we're first setting up. And then over here, where are we? When we are cleaning up the sandbox environment, we'll try and clean up the tempter. And then in the exception handler, what do we do? So valid Chrome, not content, process tempter. Create path from file. Path from file, get new path. What are we doing? What are we doing? What are we doing? Open. If mini dump ID is null, we assume the dump path contains the full dump file path. API data, ensure trailing slash, build tempter, there's all these file things. Don't care, don't care, don't care. Right, annotations, right, that's the code we were looking at before. Got rid of a bunch of code. Get extra file for child PID. Who calls that? Extra file sounds like what we want. One side effect of this function is that it deletes the gecko child crash PID extra file if it exists once processed. Write extra for mini dump. Write extra for mini dump for PID. And then in here, which is what? What is this function? When we initialize the crash reporter, we will get the content process tempter. So out of memory abort handler. Extra for mini dump. Okay. And then we have a test. Try crashing with an out of memory. Wait, so it's just putting it in extra. That's interesting. If I understand this correctly, the data from the crash should just go into the extra file, which we should be sending, if I'm not mistaken. That function writes the annotations into temp file, but it doesn't get picked up by the info barcode. Really? Write extra for me down. Append extra data. Write extra data here. And then we have append extra data. Has more extra data. We get an extra file for child PID. So there's an extra file for the, for the content process. There's an extra file for the content process. That's interesting. So I think the claim is that we're not sending the extra files that the content process creates. Wow, this is still building. It's taking forever. How's my stream doing, by the way? Am I dropping frames? Not too many, about 2.5%. It's not so bad. Not so bad. So I guess one way we could do this is testing crash submit. How does crash submit work then? Crash submit is what we use to submit those crash reports. Extra. Pending mini dump. Get all pending mini dumps IDs. Sounds like I need more information about this. Well, while I'm waiting for this build to finish, maybe I'll ask. I'm gonna ask the fellow who wrote this patch if I understand it correctly. What I think is happening is uh, whenever a content process crashes, we'll do what's called a paired mini dump. So we collect a stack in the parent process, we collect a stack in the content process. And in the parent process, we do this work of collecting what's called the extra data. So information that's not just in the stack, but extra information, like kind of meta information. And I think what he's done is he's made it so that we can collect meta information for the content process as well. Hey, I have a question about your work in this bug. Your work in bug. I'm also live hacking. Mind if I ask you? Okay, so I'm going to see if he's going to let me ask him what's going on in here. Just waiting for him to respond. Waiting for him to respond. Meanwhile, let's see. How does I would expect then, because the tab crash handler, content crash handlers, all uses the same mechanism. When we submit a crash report, send to tab crash page, maybe send crash report, we use the same mechanism. Submit crash submit dot submit params. That's fine. How do I do this? Here's fine. Not on screen. Not on video. Anything. So, aclods, just IRC. So, I'm mostly looking at this because of bug. See, this is what I mean whenever I say, oh, our build's done. No plan survives breakfast. I've been sidelined, and now I'm looking at this bug, but I'm just doing research at this point. This seems pretty closely tied to the work you did in that previous bug, and I want to know basically how it works. I think what's happening is that in your patch you made it so that .extra files are created for content processes. They go down, right? Let's see what he thinks about that. Stretch. If you're interested in hanging around, like if you're interested in being in this chat as well, I mean, I'm in the hash E10S room is where I'm asking a clots. That's the pound symbol, then E10S. E10S is short form for electrolysis, which is the multi-process project that that involves content processes and the crashing stuff. Let me just check and make sure that the stream is still behaving. Stream still seems to be behaving. I nearly infoed you on that when I pinged in it. Okay. Excellent. And are we, okay. Have we been successfully getting those content process.extra files? So Aaron Klotz said I am right. So my read on that patch was correct. And that was mostly a guess just based on what I'd seen. Have we been successfully getting those content process.extra files from about tab crashed? Like, has it worked? Have we been receiving data from the new .extra files? So, meanwhile, back at the wrench. Yes, in general, we do not see those annotations in crash stats. Great. Interesting. I ask because both the About Tab Crashed page and notification bar use the same submission mechanism. So I don't fully understand why the notification bar would skip those content process.extra files. I'm just going to copy this into my notes because that's useful. But okay, but I guess that's my job to figure out. Okay, I just really wanted to know if my read on your patch was in the ballpark, and it sounds like it is. Thanks. I haven't touched the code in a while, but I think there may have been some additional changes since I worked on it. Maybe there was a regression or something. Anyway, you're welcome. Good hunting. Okay. Maybe there was a regression. Interesting. But this was 2 months ago. From the info, I think we don't get the crash reasons it's attached via prepared child exception. The function runs annotation to a tough file, I believe, doesn't get picked up by the info bar code. No, that's about the crash, not about the crash handling. Interesting. So, having talked to a Klotz, it seems like bug 1, let me just write a summary of what happened. Bug, what was the bug? 1236108. Bug 1236108 made it so that the content process, when it crashes, creates both a mini dump as well as its own .extra file called child crash something or other dot extra. Oh, you know what? I wonder if that's because mini dump as well as its own dot extra file. Maybe there's some code inside where we're scanning for unsubmitted crash reports where we're not seeing it because of this file name being different than what we expect. That dot extra file is where the information we care about is. Strangely, we've been apparently getting the information from that dot extra file from about tab crashed, and both about tab crashed and the notification unsubmitted crash report notification bar both submit using the same mechanism. Anyhow, I'll look into this. Take assigned so I'll just need info myself. Maybe I can like figure that out later today. In the meantime, we've got our build here, and what I want to do is, or I've got it compiling, and so we're calling frame pointer stack walk, and you know, nothing's happening in here, but I'm wondering whether or not we'll get interesting data in here. And I'm trying to figure out uh, uh, how best to trigger it, because whenever we do when we set up gecko child force paint, I think the second argument that we set up for when we set up the thread, yeah, the background hang monitor, the second argument is how much we consider the amount of time we consider a perma-hang to be. And for that, if I shrink that right down, then I think we'll, like a perma-hang is when we'll try and collect a native stack. That, I think, might make it simpler. Perma. Okay. So, build that. See if anyone's chatting. Quaddle has joined. Hello, Quaddle. Nice to meet you. And our build is done. So let's see. I'm gonna run. I'm gonna try and get it to collect a native stack. I'm gonna attach my debugger actually. Performance, what's the content process we have here? 26593. I'm actually gonna, here's what I'm gonna do. I'm gonna drop down to a single process, a single content process, because I don't have to deal with making sure I'm attached to the right one. So I've reduced the number of content processes I can open up. And let's go to, well, a classic choice is going to like the W3C HTML5 spec and trying to switch tabs when that's loading. That's my like classic choice, because we hang the content process because it's trying to do layout so much layout. In single process Firefox, the entire browser hangs. Okay. So running plugin container, and now I'm going to add a breakpoint to, what did I call it? Stack walk callback? Thread stack helper. Am I inside a namespace? Namespace Mozilla. Mozilla stack walk callback. Yeah. Okay, so we have our breakpoint set, and now I'm going to try and hit that breakpoint by doing, let's see, I'll load the HTML5 spec, and now interesting. I was definitely hanging for longer than I I definitely hit the hang, but I never entered. I don't think I entered get native stack. Let's double check. Break in thread stack helper get native stack. We will break here. Oh, maybe it's because I was supposed to pass the memory address here. We'll see. So reload. Yeah, I never even call get native stack. Oh, I wonder if that's because I'm not on the right thread. Do I have to? No, because this should break if any thread hits that line. Huh. Okay. Well, let's go a little deeper. So thread stack helper get native stack. Who's supposed to call that? Get native stack. I think it's supposed to be called by report permahang. Here, report permahang. So let's see if that one gets entered. Okay. Okay, we do enter report permahang, and then we try and get the native stack. Oh wait, why did we skip that? Hang stack. Oh, we're trying to get a reference to hang native stack. If the stack's empty. Oh, what is the stack? The stack isn't empty apparently. Under get native stack. Stack.empty, get native stack, but it's null. It's supposed to, this is probably broken. Okay, so that's our problem, I think. Get native stack is reporting itself as being empty when or as not empty when it is. So background hang thread is the name of the file. Or background hang monitor. Get native stack. I'm just gonna like get rid of this condition for now. Let's try that. We're gonna detach, and then we're gonna quit. We're gonna try this again. Quit, I say. Yeah, contra process is hung. The main thread is busy trying to parse all that HTML5 page. This fellow in the Twitch chat says, "Yo, what is this, Kappa? Are you making a website?" I am not making a website. I'm working on the Firefox browser. I'm attempting to make it faster. I'm attempting to I'm working on a tool that will allow us to find out when it is slow and where it's being slow, so we can try and speed it up. That question comes out to me from Pukati Beste. I'm probably butchering that. I'm sorry. Okay, so let's try again to attach our. Yeah, he says nice. Yeah, glad you like. All right, let's attach. What is that trash language? What, the one I'm writing in? C++, and it is trashy. I can't stand this language. Well, it's only okay. Let's see here. I'm gonna set a breakpoint on report permahang. All right. So now I should be able to trigger the permahang by force reloading and then Hey, hit my permahang right here. So now we enter get native stack. And then we're going to do the stack walk thing. Oh, you know what? I skipped it. But I've set a breakpoint here. We'll try it again. We'll try it again. Because I skipped over this, and I believe frame pointer stack walk is synchronous. So after I skipped it, all of the calls to stack walk callback happened. There. Continue. Interesting. Interesting. I expected us to enter. What? Step over. Why didn't we enter frame pointer stack walk? Break frame pointer stack walk. I assume that's where we want to go. Where are we? Oh, I'm in frame pointer stack walk. Why am I here? Why am I breaking? Oh, this is the... How many frames am I at? What the heck? Background hang monitor has called me from where? How? What is happening? So one of the problems is that I'm running what's called an opt build. He wishes, okay, this is amazing. Pocatu Beste says he wishes he knew C++. I only know Python at, let's say, medium level. I can handle stuff, but I can't call that. I know Python that good, so I can make anything I want, Kappa. What's Kappa? I'm really new to Twitch. I don't really understand what the what it means. Is that like, is that some kind of Twitch slang? Oh, it's a face. It's a face. Also, cool kids don't use debuggers. We use the terminal and just brute force the blank out of it until it works. And then a face. Interesting. To each their own. I fully commend you for using printf debugging. I hear that. Kappa Psi, the best meme ever, was the worker of Twitch. Well, I have a lot to learn. I'm new to Twitch. I don't really. I'm brand new. I don't really understand what's going on. I've been broadcasting for a while. This is the 89th episode of the series, but I only started broadcasting to Twitch a few days or a few weeks ago, and so this is my first time, and I've still got a lot to learn about the culture. So I don't know who Kappa is. I'm also going to do a debug build because uh, I need to get a better sense of where I am in the code. And in an optimized build, there's all this inlining that occurs, all this optimization that occurs. So attaching my debugger gets very confused over where it is. And I'm having a harder time reasoning about it. So I'm going to do a debug build, which will allow me to get rid of all those optimizations and step through the code properly. So while we're waiting on that, let's shift back to the other problem we were looking at, which is how come whenever, I really didn't give you a lot of context for this other bug that I was given an alert about. So we collect crash reports in Firefox. When the browser crashes, in the best case scenario, we were able to collect a crash report, and sometimes the user submits them, sometimes they don't. Um, in the event that they don't, we've added this feature where it's possible that the user didn't submit the crash report because they didn't know they could submit them, or they didn't have the opportunity to submit them. So we have this feature now in Firefox, I think up until early beta. It holds. It's not out to release, and I don't think it'll ever reach release. But we have a notification bar that comes up at the bottom of the screen that says you have a number of unsubmitted crash reports. Would you like to send them? And when we send that crash reports from that data, from that info bar, that's great. But for some reason, some of the information is missing whenever we send it that way, and I'm trying to find out why. There's more. Also, there's better Twitch TV at extension for browser, adds new emotes and such things like themes in your personal channel. Emotes for free. I started streaming too, but on another account. Very interesting. Very interesting. I did not know that. I'm new to everything about Twitch, so thank you for introducing that information to me. So while we're waiting for our debug build, I'm going to try I'm going to try a couple of experiments. Can I make, if I make the content process crash, then can I, if I make the content process crash, these get created. I think maybe what I want to look at is the unsubmitted crash handler. The unsubmitted crash handler is what operates for scanning for pending crash reports. So this does the work of like asynchronously checking the file system for pending crashes. Pending IDs async. Hope you know that there are hosts on Twitch where a channel with or without views can host your channel, and all people from his channel come to your channel. I did not know that. I did not know that. And don't apologize for your English. It's fine. Don't. It's absolutely fine. Talking to Bukatayub's Beste, who I'm not pronouncing that correctly. But this is interesting. So we do this pending IDs async thing, and that does the work of checking the pending path, and looks for any file that ends in .dump, and does it, how about for extra? Get pending mini dump. Look, like here it adds get pending mini dump. That's interesting because this doesn't have that gecko stuff. The what was the prefix? Gecko child crash PID dot extra. It's expecting ID dot extra. I don't even know what this is used for. Get pending mini dump is used when we attempt to submit here. Get pending mini dump. That's interesting. So Gecko child crash. Who does the work of actually submitting that stuff? Gecko child crash. Oh, hold on a second. I'm missing some information. I am missing some information. Hey, I have a follow-up question. I'm going to ask Aaron Klotz. Mind if... Here, he was cool with it before. Reading this. Is it the intention that when the parent process writes the .extra file, it combines it somehow with the .extra file from the content process? So there's only a single .extra file. So my assumption in there is wrong if that's the case. How's our build doing? Build's still going. Zahid wants me to know that I should use Atom. It's open source and it supports Rust too. Atom. That's the text editor that Electron spun out from, I think. Yeah, I should probably give that a shot. I've been using Sublime for a number of years. I'm happy with it. I'm it might be time to try something new. Maybe I'll give it a shot next week. Maybe I'll be running the Atom editor, assuming it's not super heavy. What I like about Sublime is that, at least for me, it feels pretty light. Bum, 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 bum. Content crash handlers. So whenever the unsubmitted should show pending notifications, show pending. When we submit reports, we'll do extra key vars, crash submit, dot submit. Params, extra key vals is none. Create a new submitter. Get pending mini dump. When we submit, we get the extra file. If the dump doesn't exist or extra doesn't exist, then it failed. Our file may or may not exist. Extra key vals, parse key vals from file extra, and then parse key value pairs from file. Where does that come from? From key value parser. Okay. It's synchronously, sync IO, sync file input output. It will parse key values from the file. And then it will see if there are additional mini dumps. Additional dumps, push name dump, then notify status submitting. So this should be submitting the extra file. What does Aaron say? Yes, the extra file should be the union of the annotations from the parent and the content. Okie dokie, thanks. So my initial understanding was slightly off. Actually, more interesting is that with this was the file that I would point at before, and I want to permalink. More interesting is that with the function at 1 is that when constructing the .extra file for the parent process, constructing the .extra file for the main dump, the content process .extra information is merged into it. I wonder if what's happening here is that sometimes this function isn't running. Perhaps in the event that the parent process hasn't also had a mini dump collected for it, i.e. it wasn't a paired mini dump. So just writing my thoughts there. Man, have not written a whole lot of code just yet, waiting on this build to finish. Sorry about that. I know that you probably came here to watch some code. So some more questions from the Twitch chat. This fellow's asking, how much time do I code and what languages do I know? Well, I how much time do I code? I work 9 to 5 usually ish, something like that. And in that time, I do have meetings and I do support and mentoring for people. I'd say I write a couple of hours worth of code every day. But it's a lot like this. It's a lot more reading code than writing code, I find, especially with an application as large and complicated as Firefox. It's a lot of reading code, trying to understand what's happening. What languages do I know? JavaScript. I tend to write in JavaScript and C++. I know quite a bit of Python as well. A little bit of Ruby. I've started to dig into some Rust. Um, I used to write in Basic, QBasic. That's what I started with. What else do I know? Objective C sometimes. Um, CSS and HTML. You can call those languages. Those are real languages. And he wants to know if I'm talking about Atom, and if so, if yes, it's awesome and don't eat much resources while you've seen. Okay, so I'm convinced. 2 people have said I should try Atom. I'm gonna try Atom next week, or you know what? Right now, I'm just gonna get a copy of Atom. Let's try it out while we're waiting for this build to finish. Atom editor. Let's do it. You've convinced me. Let's try this thing. Download. Oh, oh, shoot. And you know what? We're gonna have to call this episode right now because I just realized I have a meeting and I've gone long. My apologies. And I'm so sorry. So I'm gonna have Adam ready for next time. It's gonna take me a while to download apparently because it's either large or my network's slow. Probably because the network's slow because I'm streaming so much. Thank you so much for watching this episode of The Joy of Coding. I know it was a little frustrating. I went around all over the place. I didn't do as much coding as I probably as I wanted to certainly. Thank you so much for watching, and I will see you next week where I will be doing more streaming of hopefully some actual coding. So let me just transition back. Thanks for watching. Take care. Bye-bye.
The joy of coding.
See ya.